Hey guys, so this is our third and last lesson of the week. Our final function operation is called function composition. Composition is not like arithmetic, add, subtract, multiply, divide. It's something unique that just really applies to functions. The notation for function composition is kind of a small letter O. I'll talk about that in a minute. The idea behind function composition is you're actually plugging a function into another function. So we've done examples in the last couple of days where you plug numbers in and work out an answer. Well, that was yesterday, actually. But now we're actually going to plug a function into a function, or possibly plug a function into itself. That's a thing. So we'll look at see what that looks like. And then we could do all of the above with numerical values. So plugging in a number like we did yesterday along with composition. So it might get a little complicated here. Notation. So what you see here is f of g of x. That's pronounced f of g of x. Do not confuse that with this. So not equal to f times g of x. These are two completely different things. The dot means times. The open circle, it basically means the word of, but it represents the concept of composition. So it's a small letter O, like in the word of. Another way to express function composition is like this. F of g of x, like we would say f of x, f of 5. This is f of g of x, just like this is f of g of x. I hope you can see where I was writing up there. So in general, with function composition, you're plugging the second one, meaning the second function, into the first one, the first function. And I don't know how my screen did that, but okay. So I'm going to scroll down to my first example, number 2, and show you exactly what this means. And then the examples will get a little more complicated as we go. So let's look at this. G of x, 4x plus 2. H of x, 2x minus 5. We are asked to do the composition g of h of x. So we want to plug the second function into the first function, g of h of x. So I start with g of x. That's 4x plus 2. But notice instead of x, I put down a blank set of parentheses. Inside of those parentheses, you need to plug in h of x, the other function, which is 2x minus 5. So the second function here went into the first function there. And then you work it out. You do some basic math here. Distribute the 4. You get 8x minus 20 plus 2. And then you combine negative 20 plus 2. You get 8x minus 18. So number 2 should be 8x minus 18. Oh, holy cow, how much scrolling am I going to do? There it is, 8x minus 18. Scrolled so much I almost forgot the answer I was looking at. Now, if you didn't follow that, go back, move back and watch it again. Watch it a couple of times, see if that makes sense. The second function right here got plugged into the first function right there. If you're good, we'll go on to number 4. F of g of x. That means f of g of, t. So we're going to plug the second function into the first function. We're going to plug this whole thing in right there. So start with f of t, 4t minus 5. But did I write down t? No, I wrote down blank parentheses. In the parentheses, you need to write 3t squared plus 4t. Having done that, it's just simplifying. Distribute the 4. 12t squared plus 16t minus 5. Combine like terms if you can. Well, you can't here. There are no like terms, so that should be the final answer. Number 4, 12t squared plus 16t minus 5. And right there. So putting a function into a function and then simplifying it. Let's look at number 6. G of f. G of f of a. Okay, so we got to plug the second function into the first function. Start with g. All right, this might look a little complicated. a squared minus 5a. Where both of those a's are, I put blank parentheses. What am I going to put inside the parentheses? This. Negative 3a plus 4. And it goes in both places. Now we need to simplify this, and that is going to be easier said than done. In fact, it's a good thing I gave myself a little bit of room here. Negative 3a plus 4 squared means negative 3a plus 4 times negative 3a plus 4 minus 5 times negative 3a plus 4. So when you square something, you multiply it by itself. And how do you multiply that by itself? Well, we've been there, done that. It's the FOIL method. First, positive 9a squared. Don't confuse my 9 with my a. I know they look a lot alike. Outside, negative 12a. Inside, also negative 12a. Last, positive 16. And then in the next set of parentheses, I don't FOIL, I just distribute. So negative 5 times negative 3 is plus 15a minus 20. Now I combine like terms. 9a squared has no like term. Minus 12a is negative 24a plus 15a. Well, I'm going to write that down. I can't keep track of it in my head. 24a plus 15a. And then the plus 16 minus 20, that's negative 4. I can do that in my head. I don't need to write that down. Now, negative 24 plus 15, I believe that's negative 9. 9a squared minus 9a minus 4. Let's check and make sure we are good on number 6. Oh, come on. There it is right there. So a lot of steps to this one. The concept is the same. You plug the second function into the first function. But because the first function had the variable twice, you had to plug it in twice. So that was, a complication. The second complication, you might call it, was having a square where you had to multiply this by itself and FOIL it together. So that was another issue. And of course, at the end, combining like terms was maybe a little more complicated than it has been in some of the other problems. Okay, go back and rewatch this one if you had any trouble. Number 8, h of h. So we need to plug h into itself. How do you do that? Well, I'm going to write negative 4a plus 2. Of course, instead of a, I put an open set of parentheses. What am I going to put in those parentheses? I'm going to stick the original function, negative 4a plus 2. So I put a function inside itself. Now distribute 16a minus 8 plus 2, and that becomes 16a minus 6. Number 8, that should be the answer. 16a minus 6, there it is. Number 10, same thing. h of h, 3x minus 3. Instead of an x, I left open parentheses, and now I need to plug that into the parentheses. Oh, I've left something off here. Normally I do this, so it's h of x. That's not necessary, but I'm just trying to be consistent. This is h of a. So you kind of see what's being plugged into what when you write it that way. Okay, so back to this. 3x minus 3, I took out the x, and now I need to plug 3x minus 3 in. Distribute here, 9x. Distribute here, minus 9, minus 3. And that works out to be 9x minus 12 for number 10. Let's check number 10. Where am I? 9x minus 12, right there. So good, good, good. So far, so good. Number 12, h of g of 4. Excuse me. Okay, so like yesterday, there's maybe an easy way and a hard way. You can plug h into g, get that answer, and then plug in a 4. Maybe I'll do it that way. I'll do it the hard way first. So g of h of 4 G of h means I start with g, 4x minus 5, and I plug in 2x plus 2. If I work this out, I get 8x plus 8 minus 5, which is 8x minus 3. Now what I'm supposed to do is take that answer and plug in a 4 right here. So it becomes 8 times 4 minus 3. 32 minus 3 is 29. So the answer number 12 should be 29. And I'm calling that the hard way. Where am I? Oh, 35? Uh-oh. What did I do wrong? Oh, I'm dumb. Hey, class. What's positive 8 minus 5? Is 8 minus 5 negative 3? Heck no, it's positive 3. So that would be a plus 3. 32 plus 3 is definitely 35. So that's one of the reasons I give you the answer key. So if you make a mistake like that, you know right away you can check it and fix it, and you don't have to go a day or 2 or 3 with a wrong answer and not even know it. Okay, so there. So that's the hard way. What's the easy way? Well, I'm going to rewrite over here g of h of 4. So plug the 4 into the h first. Sorry about that. So this is 2 times 4 plus 2. That's 8 plus 2, which is 10. Now take this 10 and plug it into g. G of 10 is 4 times 10 minus 5. That's 40 minus 5, 35. Same answer. So it's like you plug the 4 into the h, get that answer, and then plug that answer into the g. It's kind of like a chain reaction. Do this, take that result, and then do something else with it, and it just kind of builds on itself. Let's look at number 14 that way, what I'm calling the easy way. So we're going to plug negative 2, well here, let me rewrite it this way, f of g of negative 2. I'm just going to do the g part. 4 times negative 2 minus 2. That would be negative 8 minus 2, which is negative 10. Now take that negative 10 and plug it in here. 2 times negative 10 plus 4. That's negative 20 plus 4, which is negative 16. Number 14, the final answer should be negative 16. Not negative 10, that was like an intermediate answer. The final answer is negative 16. And there we go. Let's see, we got another one. H of negative 7. Okay, so we need to plug a negative 7 in here. 3 times negative 7 plus 1. That's going to be negative 21 plus 1, which is negative 20. So that's like our intermediate answer. We're doing h of negative 7. So far, I've done this part. Now I need to take that answer and plug it back in. So that's going to be 3 times negative 20 plus 1. Negative 60 plus 1, which is negative 59. So the final answer would be negative 59. Right there. Okay, if you can accomplish everything that I've done, you can get 1 through 15, the odds done, you are on track. You are doing great. If you need extra effort, if it takes work, that's fine. I don't expect everything to come easy. I'm trying to teach it as though it's easy. I know this can be kind of complicated for some people, so do your best. Make sure you contact me if you have questions. The rest of the paper is sort of a stretch. It's a little above and beyond. So this is like you're being given the answer. Can you come up with a composition that would give you this answer? So I want two functions, f of x and g of x, so that when you plug g of x into f of x, it gives you h of x. So what two functions can you cram together that will give you this as an answer? So we've got f of g of x equals radical x squared plus 3. Or f of g of x equals radical x squared plus 3. What looks like it's being plugged in to another function? to me, it appears that f of x is the square root plus 3, and g of x is the x squared that's getting plugged into it. So you kind of have to like really think about this and kind of twist your brain around, and what could you do that would give you this as an answer. This is not something you're going to be tested on. This isn't really even required for homework. This is if you're up for a little challenge and you want to maybe extend your thinking a little. Now, the one thing about this is there's more than one possible right answer. You could have said f of x is x plus 3 and g of x is square root of x squared. If you plug this in here, you also get square root of x squared plus 3. So this is one of those scenarios where there's more than one right answer anyway. So you might get it right and go to check yourself and you got a totally different answer. So number 18, yeah, that's what I got here. So number 20, well, rats. Not a lot of variety here. My number 20 is a lot like number 18. So f of g of x is supposed to equal this, or f of g of x equals this. What could f of x possibly be? And what could g of x be that when you plug it into here, you get that? So just kind of an intuitive thing, you got to figure it out. To me, I kind of see, okay, f of x is like your x plus 5, and g of x is your square root of x. If you plug this in right here, it'll turn into that. So I'm saying this is my answer. Whoa. Oh, nope, they have a completely different answer. Mine is still right, but let's look at their answer. X plus 4, square root of x plus 1. Okay, if I do f of g of x, if I plug this in right here, I get the square root of x plus 1 plus 4. And then when you combine the 1 plus 4, you get square root of x plus 5. So yeah, my answer is still right. If you plug this in here, you get that. But there's multiple right answers. In fact, there's infinitely many right answers, to be honest with you. This could be, I don't know, x of 40, and this could be minus 35. Those still add up to 5, so it would work. I mean, there's tons of different ways to do these. So what am I trying to say right now? I don't want to keep you listening to a video forever. 17 and 19 are optional. You don't have to do them for homework. You only have to do up to 15. If you're up for the challenge, try them. But your answers might not even match the answers down here because there's infinitely many correct answers. So do your best if you're up for a challenge. Otherwise, stop at 15. If you're having trouble, contact me through the normal means, email or comment, and I'll get back to you as soon as possible. Good luck on this.